Hi, I'm going to try to go over some of the stuff that we missed on Monday and Tuesday. So first, this week, we are going to be talking about doing translations, rotations, and reflections on graph paper with pictures. This is really not in the book like I want it to, so this is on graph paper. So I'm going to show you how to do it, and then I'm going to be putting up a worksheet for you to work on. Okay, so these are all transformations. Transformations, as we recall, are translations. That's moving it. Moving up, down, left, right. Okay. A reflection. Basically, we are reflecting over a line. And basically you get the mirror image. Okay. The last one is a rotation. You rotate around a point. And your figure ends up being pointing a different way. Facing different directions. Okay. So basically, let's start with the translation. So here we have our graph paper. And if I have just a triangle, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 1, 2, 4, 5, 6, 7, 1, 2, 6, 7. So let's say I have this figure. Some sort of triangle like that. Then when I'm doing a translation, I may say up 7, left 2. Okay, so what that means, you can start with 1 point, you can do all 3 points, but basically what it's going to mean is from this point we're going to go up 7. 1, 2, 3, 4, 5, 6, 7, going up 7, and I'm going back 2, so back 2. So my first point is going to be right there. This point has been moved up 7 and over 2. The same thing with this. Now we're going to move this one up 7 and over 2. So this is one above, so it's going to be one above here. It is 1, 2, 3 back from this, so it's going to be 3 back from this. So basically right there. Okay, I kind of went a little crooked on that one. This one is actually going to be very much similar to that one. It just won't go as high, okay, because it's on the same point. So again, I'm going up 7 over 2. So here's my 2. So I'm going right here, but I'm going up 7 from here, which I've drawn that to be on the 1. So 1, 2, 3, 4, 5, 6, 7. So my next point is going to be right here. And now I've basically drawn that triangle. I have moved it up 7 and over 2. So to do that, you just move each point up 7 and to the left 2. Depending on what directions you're given here. If it's moving it down, then it's moving it down so many, and to the right so many, depending on what you're given, if it's left, right, etc. Okay, so that's how you do translations. Translations is just moving it. The figure does not change. It's exact same figure. In fact, in all transformations, you have congruent figures. They do not change. Just the direction or placement on the paper, all that is what changes. But the actual object is still congruent. It's just been flipped, moved, that kind of stuff. Okay, so that's translations. It's the easiest. It's very, very easy to do. A reflection is always over a line. Okay, so let's say we have this, and I'm going to draw this picture like this. Okay, so if I wanted to reflect it over the y-axis, I have to know its line of reflection. So then basically what you're doing is you're going out here, you're figuring out how far these points are, and that's how far you want to go this way. So they're basically symmetrical in the respect to these first few points. So that's going to look like that. But then this point is still going to go in the opposite direction because it's going to reflect. And so it's going to go out, and we would have something like that. Again, you can look at points, figure out where these points are, figure out where that point is and where it would have to be over here. Okay? If it's over some other line, like let's say it's reflecting around y equals 1, and I have this right here. Okay, so reflecting across y equals 1, that is a horizontal line like this. This is y equals 1. You would determine how far up these are, okay, and you want to go basically that same distance. Okay. And you can usually count because I'm going to give you these. And then you're going to find that third point, and you're going to get a reflection. Now that reflection, this is your center. You can see that they're both the same, just flipped around across that line. And so that's really what a reflection does, is it just flips it over one line or another. Okay, so when you're looking at these, that's what you're doing, is you're reflecting over a line. Okay. Rotations might be a little bit harder, especially if we don't rotate 90 degrees or 180 or 270. So rotations are always around a point. So let's say, and sometimes it's around the point of origin. Okay, so we can say that. But let's say that it's around the point of origin. So we're rotating around the origin. It has to be a point that we're rotating around. And for ease right now, we are just going to rotate 45 degrees. 45 is half of 90. So think of half of a 90-degree angle. We're going to rotate that much. Okay, so if I have a picture that looks like this, I'm going to make this a little bit easier. There is my original drawing. Okay, I'm rotating around this point 45 degrees. So that means that this point right here is going to move 45 degrees that way. Okay, this point here is going to move 45 degrees this way. Here's my 45. It's going to be at 45. And then this point is also going to rotate 45 degrees. Let's see, wait a minute. From here to here is 45 degrees, yes. Okay. That's my 45-degree angle. So So now this point is rotating 45 degrees, which is really gonna, I think, put it right about on here, but we have to rotate it. What I do, to be honest, I have a hard time with these. Some people see these fantastically. I don't, okay? So what I do a lot of times is cut my figure out, and then as I rotate it, I can see where it needs to lie, okay? I think this is gonna lie about like that. That's not drawn to scale, but it's gonna look about like that. So it's rotated 90 degrees or 45 degrees. But again, you can cut out the figure and then rotate 90 degrees, and if you need to, just take it from here. You're gonna go 90 degrees. You're either going here to 45 degrees, that's 45 degrees, and this is gonna go 45 degrees, so you need to rotate each of them. But if you rotate this point 45 degrees, it's going to show you where you end up. So if you take it and you rotate it 45 degrees, it will end up where it needs to be, okay? Whoops, rotate 45 degrees. Okay, so to me, rotations are the hardest. I have the hardest time drawing them. I have the hardest time figuring out how to do them. But with practice, you can see it. A lot of people can just see it. And I envy them because that's something I don't see. But I can make it work by cutting it out and doing that rotation. I just put the line of 45 degrees and I turn it, and that way it gets onto that line. So I've rotated around 45 degrees. You're trying to keep this distance the same as this distance. So these distances should be very similar that you're using, or I should say these distances should be very similar, because you're rotating this 45 degrees, and so it flips as you're rotating. And so that's where this comes out to there, and then it will be kind of a lopsided shape. It won't be exactly this way because that would be 90 degrees. So it would be more at an angle, because 45 degrees is halfway in between 0 and 90. So that's really what you're doing with transformations and translations on a piece of graph paper. And on graph paper, it's much easier because you have actual points marked, so you can actually rotate them and make sure you are at the right points and they're drawn at those points. Your distances are the same and all of that, so you can make sure it's very accurate when you're doing that rotation. Okay, so I'm going to give you some work to do on these on worksheets. This is mainly what we're looking at. Next week, we're going to talk about same thing, translations, reflections, and rotations. Maybe not as much rotations, but translations and reflections of linear functions that we have, the base functions of all, not linear functions, all functions that we have, and what numbers cause them to be translated, what numbers cause them to be reflected. And so we'll be talking about that. We'll be using some graphs instead of shapes, and we'll be moving things. And that's more the advanced algebra portion of this class, is where we're actually looking at functions, but we're doing the same thing. It's just showing where they show up and where they don't.